Hi, we are from Department of Chemical and Environmental Engineering, and today my group and I are going to present about our experiment 3 and 4, which is pumps and valves for course Chemical Engineering Laboratory 1. And here we would like to thank our instructor and our lecturer, Dr. Mohamad AMRAN bin Mohamad Saleh, for guiding us throughout the semester. And now I would like to introduce my teammates, and we are from group 3. First is Noor Aishah Binti Mohamad Ali. Next is myself, Mohamad Ibrahim bin Ayub, and my teammate Mohamad Ikhwan bin Mohamad Shaffie. And lastly is Siti Aishah Binti Mohamad Isham. Let's move on to the introduction of our experiment. Pumps are used to transfer energy to an incoming fluid. The pressure or velocity of the fluid increases, which helps the fluid overcome physical barriers such as pipe friction and eye changes. Pumps have a few operating characteristics. They should give some importance, which are pressure drop, efficiency, power, and head loss. In practice, however, the actual pump delivers spec that is less than that being calculated and lead to the pump efficiency. So this is basically the graph which represents the head curve and efficiency and BEP, which is known as base efficiency point. So base efficiency point is referred to the flow at which the pump operates at the highest or optimal efficiency for a given impeller diameter, while the efficiency is the pump efficiency for a given flow rate. So let's move on to our objective of our experiment, which is to measure the operating characteristic of a pump.
Hi everyone, I am Aishah Binti Halil and my metric number is 207C33. I will continue this presentation by explaining the theory and method for this experiment. Generally, pumps work primarily by transforming the electrical energy into motion. So flow rate, head loss, and also the efficiency are the three analytical models that can be used to evaluate the pump performance. So as you can see here, these are the formula that commonly used. Firstly, the power. Necessarily to determine theoretically, since it defines the rate at which work is performed. However, in reality, actual pump will deliver less power due to the many reasons. So because of that, pump efficiency can be measured by dividing the output with the input. Lastly, the head loss also is important and can be calculated using this formula. Next, methodology. So firstly, the power supply on the control panel is switched on, followed by the button pump, P1, and also the processed water. Next, speed control potentiometer is fully turned in the anti-clockwise direction to the minimum value. So at this time, hand valve HV3 and also the HV4 are open, while the hand valve HV5 and HV6 are closed. However, it is important before I start this experiment, the water tank is need to be at least half filled with the water. So for this experiment, we do two procedures, which are the fixed flow rate and also the fixed pump speed. So for the fixed flow rate, the start button on the pump is pressed, and then the speed control potentiometer is gradually turned in the clockwise direction to 1,500 RPM. At this point, HV7 is slowly adjusted so that the flow rate is about 35%. And then this step will repeated for different speed as showing on the screen. Then for the fixed pump speed, the steps are the same. Just at this point, 1,200 RPM speed were employed. So, and the flow rate is differ from the 10% to 75%. So that's all from me. Let's continue with others.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Ikhwan bin Mohamad Shaffie. As for my part, I will be focusing more on the results section. And for this particular page, it is dedicated for the constant speed at 1,200 RPM for both pump 1 and pump 2. For this page, on the other hand, it is for the constant flow rate of 35%, as well as pump 1 and pump 2. And as you might see at the bottom of the tables, we have included the theoretical power and pump efficiency for these two pumps. We will go next to the graph plotting. Here is the graph of head loss against flow rate for pump 1. We used head loss delta P in bar and volumetric flow rate Q in liter per second for the Y and X axis respectively. This is the graph of head loss against flow rate for pump 2. We used the same way of plotting just as before for this one. And I will pass the stage to Aishah for the discussion of results. Thank you.
My name is Siti Aishah Binti Mohamad Isham, matrix number 207026. I will continue explain the discussion. From this experiment, we will look into the influence of changes in volumetric flow rate to head loss in single stage pump, pump 1, and multi-stage pump, pump 2. Figure 2 and figure 3, the relationship between head loss and volumetric flow rate for pump 1 and pump 2 is inversely proportional. The value of Q increases as the head loss decreases throughout the experiment. This is because when fluid flow rate increases, the differential pressure will decrease, leading to a decrease in head loss. Theoretically, the head loss of a single-stage pump is lower than multi-stage pump. The graph shows the head loss of pump 2 was slightly higher than pump 1. This is due to the fact that each impeller has a significant effect on the head loss. A multi-stage pump has 2 or more impellers, produces a greater head loss than a single-stage pump, which has 1 impeller. Next is theoretical power and pump efficiency. In practice, the actual pump delivers power that is less than calculated. From the calculation, the theoretical power is 78.2 watt, which is lower than the actual power, 277 watt. In this regard, method to characterize the operating pump is through the efficiency. In literature, the efficiency of the pump usually falls into the range of 70 to 90%. Based on the calculation, pump 2 has lower efficiency, which is 19.3%, than pump 1, which is 28.2%. This corresponds to the theory, multi-stage pump has lower efficiency than single-stage pump. This might be due to the less power delivered to the water, which causes the head loss in multi-stage pump and the energy losses by the friction in the pump. Therefore, pump 1, single-stage pump, has better performance compared to pump 2, multi-stage pump. In conclusion, the aim of this experiment was to measure the operating characteristics of a pump. Head loss is directly proportional to the pump speed and inversely proportional to the flow rate. The head loss is lower in a single-stage pump as compared to multi-stage pump. The experiment has shown that the number of impellers in the pump greatly affects the head loss. The impellers increases the discharge pressure in the multi-stage pump. Moreover, single-stage pump has better performance and higher efficiency compared to multi-stage pump. Finally, the recommendation for this experiment: first, the flow process should be allowed to run for a longer time to let the system stabilize, thus more accurate result can be obtained. The pipeline system should be frequently inspected for the presence of any external substances that might affect the pipe surface roughness to avoid minor losses. Pump direction must be followed to prevent damage to the pump. Lastly, the fluid used should be replaced often to ensure its composition remains constant, as this may affect its viscosity. These are the references for our group for this experiment. Thank you.
We have come to the last section of our report, which is the appendices. Here we would like to show you the sample calculations and the assumptions that we use for our calculation part is maximum flow rate is to be 0.975 liter per second, and the differential pressure is to be 6 bar. We also have included some formulas to calculate the flow rate as well as the head. On the right side here is the efficiency for pump 1. From here, we calculated the theoretical power and also the pump efficiency. So calculations for pump 2, we have implemented the same method just like this to calculate the respective theoretical power and the pump efficiency. So that is it. We would like to thank you for your time. Thank you for listening to our group presentation, and have a pleasant day. Thank you.